A massive surge of energy from the sun is about to collide with our planet, and the data we've compiled suggests this specific event could be the trigger for a major seismic response. Hey everyone, Stefan here from Winds of Thought. We are now within the critical window for a significant celestial event, one that unfolds not in a blinding flash, but as a sustained, powerful push from our star. A high-velocity stream of charged particles flowing from a vast, persistent opening in the sun's atmosphere known as a coronal hole is en route to Earth. This isn't a brief solar flare. It's a relentless, high-speed solar wind that will begin to compress and buffet our planet's protective magnetic field very soon. Now, the official space weather forecast predicts a moderate to strong geomagnetic disturbance, officially categorized as a storm. The severity scale runs from minor G1 levels to the extreme, planet-wide G5 events. Current projections place this incoming impact at the upper end of a moderate G2, with a significant probability, around 25%, of escalating into strong G3 conditions. So why the heightened alert from forecasters? Because this persistent solar wind stream is not arriving alone. It is about to merge with fragmented debris from a massive explosive eruption on the sun's surface that occurred just days ago. An X-class solar flare. While the bulk of that colossal explosion was directed towards the outer planets, a distinct fragment was sent on a trajectory intersecting ours, and its arrival will amplify and complicate the incoming storm's effects. This combined two-part impact is what commands our full attention today. Advanced coronagraph imagery reveals a clear, albeit partial, Earth-directed component from that major eruption. Watch as the shockwave propagates outwards into the heliosphere. You can clearly see the primary intense wavefront, and then following it, a secondary, more complex structure of ejected plasma. It's this latter element, this trailing debris cloud, that carries a definitive glancing blow directly toward our position in space. When it meets and interacts with the pre-existing high-speed stream already flowing from the coronal hole, the total energy input into our magnetosphere will intensify significantly, potentially pushing it past a key threshold. The sun doesn't just light our world. It physically moves it. For years, this channel has meticulously tracked the subtle and not so subtle energetic connections between solar activity and Earth's most restless systems. We examined the interplay of planetary alignments, real-time space weather, deep seismic energy releases, and cosmic phenomena, weaving them into a single, coherent story of a living planet. If your goal is to understand the profound, often hidden forces that shape and stir the ground beneath us, then you are absolutely in the right place. This brings us to the pivotal question. What does this incoming amplified solar barrage mean for the stability of the ground beneath our feet? The proposed link between powerful solar storms and significant earthquakes is not a simple deterministic on-off switch. A more accurate analogy is to think of Earth's vast tectonic system as a complex, finely tuned engine under immense pressure. It's always in motion, with plates constantly grinding and storing elastic energy. Solar activity, in this view, acts like a sudden electromagnetic voltage spike or a precise magnetic jolt to that already stressed system. This external jolt can modulate subsurface electrical currents and pressures, potentially pushing critically stressed fault lines past their final breaking point. The data we've analyzed from this entire year reveals a startling and persistent pattern nearly every single time a major equatorial coronal hole, structurally identical to the one facing us now, has aimed its high-speed wind directly at Earth. A significant magnitude 6.5 or greater earthquake has followed within a very tight 24 to 48-hour window. The fault lines accumulate stress, and the sun often provides the final decisive push. This specific recurring solar feature has been a key actor in this ongoing celestial terrestrial dialogue. It has been empirically linked through our tracking to some of the most powerful tremors of the past year, including that colossal magnitude 8.8 megathrust event. Furthermore, we've observed a fascinating geological ping-pong effect in the seismic data, where massive quakes have occurred at nearly exact opposite points on the globe. First in one volatile region, then another in a visible dialogue of released seismic energy. The temporal and spatial correlation is becoming too consistent and statistically notable to dismiss as mere coincidence. Let's move directly to the visual evidence. I've compiled a detailed, time-stamped visualization plotting real-time solar wind density and speed against a global seismic activity index for this entire year, up to the present day. Observe closely each major spike in incoming solar particles, marked here by these distinct red peaks, is followed within a critical 36-hour period by a corresponding sharp rise in significant global earthquake activity, shown by these blue bars. The pattern is visually striking and repeats multiple times across the timeline. It happens again and again. This isn't about the sun creating earthquakes from nothing. It's about the sun providing the decisive tipping point for massive amounts of strain energy already stored and primed within the planet's crust. A critical detail: the coronal hole responsible for the primary incoming stream possesses a specific magnetic polarity, a southward or negative oriented field. This technical detail is crucial because it directly dictates the manner in which our planet's magnetic shield will be compressed and shaped upon impact. A sustained southward polarity field, like the one associated with this event, allows solar wind energy to couple more efficiently with our magnetosphere, penetrating deeper and transferring more electromagnetic stress into the planet's interior conductive layers. The precise conditions aligning over the next day: a high-speed stream from a southward polarity coronal hole amplified by flanking CME debris, create a verified recipe for a heightened global seismic response window. So what should we, as observers, realistically expect in the coming days? The window for the initial impact begins within hours and extends for approximately 36 hours. Based on the historical pattern linked directly to this very solar structure, the period of highest risk for a major seismic event, statistically speaking, will coincide with the peak intensity of the geomagnetic storm, likely in the latter half of the window. Geographic regions along the Pacific Ring of Fire, known subduction zones, and the specific antipodal hotspots we've identified should be considered areas of heightened tectonic sensitivity during this time. This entire analysis is founded on predictive observation, not prophecy. The Earth's geophysical system is inherently chaotic, but it operates within defined energetic and physical laws. We are, in essence, tracking a potent and timed influx of external space weather energy into a closed planetary system already under tremendous and measurable internal strain. For those who take the time to analyze the converging data streams, the connection is becoming undeniably clear. If this synthesis of cosmic science and terrestrial geology resonates with you, if you want to see more content that connects these profound dots, then make sure you are subscribed to the Winds of Thought channel. Your support is what allows this deep dive research to continue. And if this video provided you with a new perspective on how our world works, please hit the like button. It genuinely helps the channel grow and reach others. I'm Stefan. Thank you for your time and attention today. And always remember, to truly understand the Earth, you must first learn to look to the sky. The sun is about to fire a direct shot at Earth, and hidden within the data is a pattern that reveals when our planet's crust will likely break. We observe these massive openings in the sun's corona. The critical ones are those that straddle the solar equator, similar to the massive feature we see here, which consistently precedes a surge in global earthquake energy. Some of these structures appear in the sun's northern or southern regions. Typically, those don't produce a significant effect on our planet because their emitted particle streams miss Earth entirely. So, what key insights can we extract by examining this data timeline? I've shared this full interactive visualization on my social media. You can download it there using any standard tool and explore the correlations for yourself. I highly recommend you do, because the complete story is in the details. The primary elements we analyze are combined in this comprehensive graphic. You'll notice several large equator-spanning coronal holes. One, in particular, has remained persistently active on the solar surface for months. That's the one.
And that is the specific structure now rotating into an Earth-facing position. Watch as it comes around again on the sun's next rotation, which is the one about to impact us right now. There are several crucial observations here. First, you can see that some of the largest releases of seismic energy on Earth occur during periods when the density of the solar wind remains exceptionally low, below 1 particle per cubic centimeter for a sustained time. Notice these two extensive zones right here, which correspond with the most intense seismic activity. Remember, the earthquake energy scale is logarithmic. A magnitude 8 event releases over 30 times the energy of a magnitude 7. So when a strong correlation appears in these high energy zones, it demands our full attention. The second key point is that there are two distinct intervals where solar wind density failed to drop significantly. For instance, in this period, it remained elevated above that critical threshold. A similar situation is unfolding in our current moment. Now, if we advance forward in time on this timeline, watch here. You'll see this pronounced dip in solar wind density aligns perfectly with this sharp uptick in seismic activity right there. Another clear example appears here, also in perfect synchronization. Observe this. There's that coronal hole, positioned to affect Earth, and note its transequatorial. If we move forward, we see another one following a similar pattern. Let's rewind slightly to get a better view of that first structure. There it was. It moved into the geoeffective position, rotated away, and we entered a brief period of low-density solar wind which coincided with an earthquake. However, those individual instances didn't trigger the highest magnitude events. This suggests a cumulative loading effect is at play, because then, when we move forward and see this substantial coronal hole, followed rapidly by another one, that sequence produced the largest burst of seismic energy for the entire year, recorded in late July and early August. Fascinating. So that's another critical mechanism you can monitor. Solar wind density, worldwide earthquake activity, and these specific coronal features appear intrinsically linked, a connection that becomes undeniable when you synchronize all the data across time as I've done here. I'll include a link to this data set in the video description for your own analysis. Our current position on the timeline is right here, where, once again, solar wind density has been elevated. We've had a couple of transequatorial coronal holes pass by. Look at this one here. And then we had this other one. Yet, they didn't seem to produce a major drop in solar wind density. Examining this section, reduction isn't very pronounced. This could indicate another loading phase is currently happening. Alternatively, perhaps this most recent coronal hole, the one about to hit us, won't depress the solar wind density dramatically on its own, but the situation is more complex. We also have that coronal mass ejection, a minor glancing impact, merging with this stream, which will likely lower the particle density even further. Concurrently, we have significant sunspot groups actively charging Earth's ionosphere. So, let's examine our ionosphere to understand that process better. Here is an animation of the ionospheric layer. Solar radiation pours in during daylight hours, causing the ionosphere to expand and hold a greater electrical charge. At night, it discharges partially, but never returns to a completely neutral state. What exactly is the ionosphere? It's the uppermost atmospheric region filled with ions, electrically charged particles. These are free electrons, protons, and other atomic nuclei moving independently. Because they carry charge and are no longer bound in neutral atoms, they can generate and conduct electric currents, moving in response to electromagnetic fields. When powerful electric currents flow in the ionosphere, they can induce corresponding currents in the Earth's crust and even deeper into the mantle. The Earth breathes electrically and the sun is its pacemaker. So what occurs when we have these large Earth-facing sunspot groups, like the ones present now? Let's review that once more as we reach the current date. When these substantial sunspot regions are aimed at Earth, they emit intense extreme ultraviolet and X-ray radiation. This radiation supercharges the ionosphere, creating a stronger energetic potential between the upper atmosphere and the ground. The atmospheric electrical gradient increases, and we must remember that many of Earth's subsurface dynamics have an electrical component. Our planet is fundamentally electromagnetic. Many of you have likely seen those remarkable videos of earthquake lights, luminous phenomena in the sky before major tremors. The evidence is compelling. These factors are critically important, yet the mainstream often overlooks the electromagnetic dimension of geology, simply because the science is still catching up. A more powerfully charged ionosphere amplifies those global electrical currents, facilitating a complete circuit closure because you also have potent telluric currents flowing underground. When you can close an electrical circuit, energy flows. If that current passes by a geological fault where the rock matrix is already under extreme strain, that extra electrical energy, let's call it plasma current, can cause molecular bonds at the critical point to break, initiating the rupture. That's the proposed mechanism for how a hypercharged ionosphere might act as a final trigger for a quake. The immense tectonic stress is already stored due to plate movements. That's the primary system. But then you have this electrical domino effect that can tip a fault over its critical stress threshold. Another celestial factor we must consider is the moon. The moon generates tides on Earth, not just in the oceans, but solid Earth tides that vertically displace the crust itself. This rhythmic loading and unloading can also push stressed faults to their breaking point. As mentioned earlier, we have a full moon approaching on December 4th. Here is a true sky chart for that time. We see the constellations, all 13 of them. The focus is here, intersecting the ecliptic plane. I've set this for the exact time of the full moon. We see the moon in opposition to the sun, configured here for San Diego. If we advance the time, you'll see the moon rise. For viewers in California and the broader US West Coast, this will be a spectacular sight. A perfect full supermoon rising on the horizon at its peak. Definitely make time to see it. This supermoon will be larger and brighter than an average full moon. For observers in the United States, the timing of its rise will be ideal. But this lunar phase is another factor converging with the incoming geomagnetic storm. During a full moon, our satellite passes through Earth's magnetotail, interacting directly with its plasma and magnetic fields. This interaction generally increases geomagnetic volatility. So, we have a multi-factor alignment. An ionosphere being extra charged by solar activity, which has already been occurring, combined with the tidal influence of a supermoon during a geomagnetic disturbance. If you appreciate this deep dive into the cosmic forces that stir our world, and you want more content that connects these profound dots, make sure you're subscribed to Winds of Thought. Your support enables this research. If this video gave you a new perspective, please hit the like button. It genuinely helps the channel reach others. Every element we track is now aligning for what could be a perfect geostorm. A rare convergence of solar, lunar, and planetary forces that has historically set the stage for significant Earth changes. As we've been monitoring, those Earth-facing sunspot regions are now positioned for direct influence. Examining the X-ray flux data, you can see a marked elevation that began back on November 27th. Notice this sustained climb. Our ionospheric layer is already in a state of heightened charge because of it. The planet's global electrical circuit is operating at a stronger capacity. Then, we layer on the impact from that recent X-class solar flare. Combine that with the incoming high-speed stream from the persistent coronal hole, add the glancing blow from the coronal mass ejection, and top it off with the impending full moon. We haven't seen a major seismic event for a while now. This combination is what we call a perfect geostorm scenario. Let me be clear, this is a forecast, not a guarantee. But the probability is elevated enough that it warrants this detailed discussion right now. All these factors are now in play simultaneously. Checking our real-time seismic monitors, we see a notable lack of major activity over the past day. Magnitude 5.6 near Fiji is the current leader. Thankfully, the concerning swarm of activity in Japan has significantly quieted down. That was a sequence we were tracking closely. I had previously issued a forecast for a potential high-magnitude event in that specific zone, based on the anomalous swarm patterns observed earlier in November. I noted that if the activity subsided and remained quiet through late November, the risk would decrease. That is exactly what has transpired, which is a positive development. However, overall global seismicity has been relatively low, and statistically, a major release is due. I assess there is a substantially increased likelihood of a magnitude 7 or greater earthquake occurring within the next week or so. That is the core of today's seismic forecast. Let's look at the data for the past year, focusing on events magnitude 6.5 and above. Our last significant event was the magnitude 6.6 in Indonesia on November 27th. Before that, we had the magnitude 6.8 in Japan alongside a 6.4 the same day. The last event to exceed magnitude 7 was in the Drake Passage on October 10th, which was antipodal to the magnitude 7.8 that struck Kamchatka back in September. These two regions have been energetically linked, firing off in a resonant opposite point pattern. Consequently, these are the primary zones I would initially scrutinize for the next high magnitude occurrence, either the Kamchatka region or the Drake Passage. We did witness that unusual swarm in Japan, and while I hope that chapter is closed, it remains a secondary area of note. When you examine the broader pattern, you see countless quakes following clear, rhythmic trends across the globe. I cannot pinpoint an exact location. We all hope no major quake strikes, or that if it does, it occurs in an area with minimal human impact. This is why a location like the Drake Passage is ideal from a risk perspective. A massive energy release there affects very few, if any, people. The same is largely true for remote Kamchatka. Look at the damage assessment from the massive magnitude 8.8 megaquake and tsunami there. It was remarkably limited. So these are efficient locations for the planet to release accumulated strain. In stark contrast, a similar magnitude event in Southeast Asia or many parts of South or North America would be devastating. The Earth must release its energy. The question is where and when. Roughly 80 to 90% of the world's seismic activity occurs along the Pacific Ring of Fire. So I don't have a single specific location for you. I would simply state that the antipodal zones of Kamchatka and Drake Passage currently present the highest likelihood for a large event. Japan would be next on my list due to the recent swarm, though I now consider that percentage lower. Beyond that, regions like New Zealand or California are perpetually considered overdue, but their timelines could stretch decades. The reality is we simply don't know with precision. Many of you have asked for an update on Campi Flegrei, the supervolcano in Italy. I cover it when there is notable activity, such as a seismic burst. We haven't seen a major burst there since February. There is ongoing, low-grade seismicity, and the overall activity level has been accelerating year over year since 2020, and even tracing back to 2005. But a significant, discrete explosive surge has not materialized recently. It remains an area for very close observation. I will provide an update if anything substantial develops, as I have done for the past 2 years. My promise is to report meaningful activity, not to generate noise about quiet systems. That concludes today's analysis. Thank you for your time and attention. I'm Stefan Burns. This channel, Winds of Thought, is dedicated to synthesizing earthquakes, volcanic activity, geomagnetic storms, solar dynamics, planetary alignments, and cosmic phenomena into a coherent picture. I release videos nearly every day. If this integrated approach resonates with you, please subscribe and press the like button. It actively supports the channel's growth. Before we close, I'll mention a current promotion on my wellness website. We offer organic herbal tea blends and themed merchandise. For viewers in the United States, you can receive 5% off your order through the end of December 2025 by using the code THANKSTEFAN as one word. These small batch teas are crafted in-house. I particularly recommend the fruit tea blend at this time of year. It contains elderberry and rose hips for immune support, and is a delicious, naturally sweet alternative. The Explore the Cosmos Within t-shirt I'm wearing, featuring sacred geometry, is also available. My sincere wishes for your well-being as we navigate this period of heightened planetary energy. Prioritize grounding practices, nourishing food, and mindful self-care. I'll be back with you very soon. Thank you.